Okay, this is actually pretty fun. Okay, Noam walks home from school by walking 8 blocks north and 6 blocks east. So I generally like to represent north by going up, 8 blocks north. The units are blocks, and the length of that is 8, and 6 blocks east. Okay. Now, this is a fun question because how far would he be walking if he walked along the street? It says, how much shorter would his walk be if there was a direct path from school to his house? Okay, so school is here, his house is here. And if he has to walk along this path, he's walking 8 blocks this way, 6 blocks this way, for a total of 14 blocks that he's walking. Okay, because there is no diagonal length. There's no straight street that runs here. But if there was, what length would it be? And we can find out then how much longer he's actually walking because he doesn't have that street. So we do the Pythagorean theorem, and we say, well, a squared plus b squared equals c squared. Okay. And what are those two lengths? Well, we've got a length of 8 and a length of 6. So then when we square them, we get, oops, 64 plus 36 equals c squared, that diagonal length, or 100 is equal to c squared. That means then that the square root of 100 is equal to the square root of c squared. And of course, the square root of c squared is c, and the square root of 100 is 10. So he could have walked just 10 blocks if he had that straight street here. This would be 10. Okay, so it said how much shorter would his walk be if he had a direct path from school? Well, if he has to walk 14, but he could have walked 10 if we had this road, then his walk would have been 4 blocks shorter. Instead of having to go the full 14 blocks, he could have just gone 10. And so we have an answer for this of 4 blocks. How much shorter is this diagonal length from walking this way along the grid?